Yeah, good day. What's up? How are you all doing today? Welcome back to this beautiful YouTube channel. I will be continuing our discussion on statistics. So, in our previous lessons, we looked at introduction to statistics. We look at the ogive, the frequency polygon distribution, and all of that. Now, in this particular lesson, we're going to start with the measures of central tendency. Um, this is not something that you are going to be learning for the first time, but trust me, there are a couple of new things that you're going to learn in this particular lesson. So what exactly is the measure of central tendency? So the measure of central tendency is basically statistical values, that refer to the middle of a data set, or statistical values that describe the middle of a data set. So the measure of central tendency is the same as the measure of location, and then there are types of measures of central tendencies. So the three that we're pretty much used to: the mean, otherwise known as the average, the median, and the mode. Right. So your second quartile, right? Because you're also going to be talking about quartiles. Your second quartile, your 50th percentile, your fifth deciles, right, or your fifth decile, right, is also a measure of central tendency in the sense that the second quartile refers to the median, right? Because that's you dividing how do I even put it? Okay, don't let me stress us out, right? But yeah, you have first quartile, second quartile, third quartile, and of course, finally, the whole thing. So the middle of a quartile is going to be the first quartile. Quartile, like, it decides the division of a data. Quartiles divide a data into four equal parts, just as median divides a data into two equal parts. So your quartile divides the data into four equal parts. So you have the first quartile, second quartile, third quartile, and of course the fourth quartile. So the second quartile there is talking about the middle values, right? So that is also same as the median. Now, deciles, divide a data set into 10 equal parts. So, and of course, that is why the fifth decile is same as the median as well. So we'll do calculations, to show some of these proofs. And then percentiles, right, divide a data set into 100 equal parts. So the 50th percentile is also same as the median. And then, so that's that. So that's why I added that to this, that halfway through all of those different types of measures, right, also describe the median. And since the median is a measure of central tendency, so um, they also are measures of central tendency. I'm not saying quartile generally, so I'm just saying the second quartile, I'm talking about the fifth decile, I'm talking about the 50th percentile, right? So yes, that's that. Now, let's talk about the mean. So what is mean? So mean is just the average value of a given data set, the average value of a given data set. So usually what you just have to do when you're solving for mean is just add up values divided by the number of frequencies. What I mean for your mean, which is otherwise known as average value, is just sum. So it's the sum, the sigma sign of fx divided by n, or sum of fx divided by f. So n is just sum of frequencies, right? So it is otherwise known as sum of fx divided by sum of the frequencies. So in situations where you have set of numbers that only have one frequency, that you have set of numbers that appear just once. So our frequency here is not going to be there, right? Because sum of our fx is going to be equal to the sum of our x. I know from observation, students don't get everything you get to tell them in a particular lesson. So I'm going to try to prove that for us to be able to understand what I'm trying to say. All right. So the mean is typically represented by a bar x, all right, then equal to all of that. So let's look at it. We have a set of numbers 8, 3, 5, 12, and 10. We have 8, 3, 5, 12, and 10, and then you are asked to find the mean. As far as the mean is concerned, you don't have to rearrange the values, so just go straight to the point. So you have 8 plus 3, 8 plus 3 plus 5 plus 12 plus 10. So how many numbers do we have in total? 1, 2, 3, 4, 5. Everything divided by 5. When you add them up, 8 plus 3 is 11, plus 5 is 16, 16 plus 7 is 28. 28 plus 10 is 38. 38 divided by 5 is going to give us 7.6. Alright, so what if you wanted to solve it like using that formula, because that's what we literally did. So I could just do like this. X is talking about the observations and then their frequencies. Alright, so X you have it's let me just put them in an array so like I read them chronologically. So 3, 5, 8, so and 10. So frequency is 1 because it appears 1, 1, 1, 1, 1. So sum of frequency, sum of F equals 5, and of course Fx is then going to be 3 times 1 is 3, 5, 1, 3, 5, 8, 12, and 10. So when we add everything together, we still get our 38. So you can see that our sum of Fx mean it's going to sum of Fx, adding up all of this together, divided by n, so equals 38 divided by 5, and that's still 7.6. So why is that the case, right? Simply because we could do this and we could do this, and then we can decide to do by x equals sum of just x over n. So this is x here. So when we try to like add up everything that is here, it's still going to give us 38 too, right? So and then we use the formula and then we get the same answer. So if the frequency of all of your observations it happens to be 1, right? So you don't need to add f to your formula, you don't need to do sum of fx, so you can just do sum of x, right? But by the time maybe like 5 occurs like twice, right? Because 5 times 2 in that case will then be 10, fx will be 10. But if you go and add x that way, let's write 5, 5 in your data, right? But if you write just 5, like 3, 5, 8, 12, whereas 5 occurs 2 times. And so if you do sum of x like that, it's not going to work out as if you are arranging it this way, because you may have very large data to deal with, and then using the formula is going to be the best thing, right? And then classifying things like this, we spoke about this in this frequency distribution, makes a lot of sense, right? So and of course in the frequency distribution, I'm not going to be writing 3, 5, 5, 8, no, right? That's the essence of the frequency column. So yeah, that's that about that. I don't think all of these things are difficult. So we are soon going to be talking about finding the mean of a grouped data, but since we are just introducing ourselves to the concept of mean, so let's just keep taking it slowly. I know you know this, so it's fine. So we want to talk about the weighted average. So what does a weighted average mean? Right? So you're looking at, if you're asked to look for the weighted mean, or yeah, the weighted mean. So what does that even mean? So you find the weighted average when your observations do not carry the same importance. Alright, so weighted average is used when the observations in the data set do not carry equal weight or do not carry the same importance. Alright, so let me give you an instance. Some of the reasons why some of you find your examination results more difficult to understand than the exam paper itself is that you're pretty much thinking that your lecturer just did exam was 70 marks, then test was 30 marks. Yeah, so 70 plus 30, or let's say in case where you had presentations, so exam was 70, test and presentation would have taken 30 between them. So whatever you must have gotten, just be a simple thing and give me my result. And you now realize that you are not the results, you don't understand it. So the issue is that the lecturer may have actually given different importance to this course. Now, for example, it could be in the ratio 2:1:1. For example, the presentation could have carried 2 weights, right? And the test and the exam carry 1 weight, right? So we're going to solve that. So which means that the lecturer gave credence, he gave more importance to the presentation, right? Than he did to with the other measures of assessments, or with the other assessments. So how then do you work the score of a student out when you begin to use weighted averages, right? So how do you use weighted average? All right, let's look at that. The mean, if you are looking for the mean, the weighted average mean, so that's just going to be, should I use a blue? So your weighted average is, you're talking about per x, is going to be equal to sum of W, which is the weight given to everything, then divided by sum of W, right? So what's W? Was sum of WX. Now let's look at an example. If the final examination scores of FSS 204, that's a Faculty of Social Science Statistics exam. So let's do this. So you have an FSS 204 paper, right? So if the final examination in FSS 204 is weighted 3 times as much as the test and the group presentation, so which means exam, right, has a weight of 3, then oh, what's this question? If the final examination is weighted as much as the test and the presentation, so test has a weight, okay, weight of test is 1, weight of exam is 3, then weight of presentation is also 1. Right, so which means the lecturer has given a lot of credence to the exam. So it may actually be that student didn't do so well in the presentation and the test, but the lecturer still wants them to pass. So maybe they pretty much did well in the examination. So how do we do it? Because if I decide to add the presentation and test scores to your exam grade, like your exam paper grade, the scores will not be so good. So let us just give more credence to the exam that was written. All right. Whoever fails the exam, then that's just village people at work, because the result is going to be really, really bad. All right. So now there is a student called Marvelous, for example, who scores 85% on the exam. So exam score. So exam score 85%, right? And then 70% on the test and 90% in the group presentation. So test score 70%, and then presentation 90%. So what's the weighted average of these students, right, given this kind of weight? So look at the formula again, sum of Wx over sum of W. So literally what we are doing is bar x is equal, what's the weight of the exam? 3. So 3 multiplied by exam score, 3 multiplied by 85%, plus 1 multiplied by the exam score, by the test score, 70%, plus 1 into bracket 90%. So everything will now be divided by the sum of the weights. So when you add up the weights together, what do you have? 3 plus 1 plus 1, that's 5. So that's 5. So at the end of the day, we will finish the calculation. The student is going to have 83%. So if this is correct, so the final score equals 83. So you see this score in your exam, like final grade 83. It's still an A, because in a lot of schools A start from 80 max. So but then you were like, oh, I got 90 in my presentation. So in your mind, you're probably doing is wait. If I got 85% here, wasn't always be divided by 3. So 85 plus 70, that should be 155. 155 plus 90, that should be like 245. 245 divided by 3. So you're expecting let's do 245 over 3. What's that? 245 over 3. So 3, this is 8. 3 and 5 is 1.20. That's 81.67% of thereafter. But then you have 83%, which is higher. Right? But it's going to be worse for a student that did badly on the exam. But if you do badly on the exam which happens to carry the greater weight, then that's going to be problematic. The average is going to be worse, right, than if it was just done via the normal mean. So yeah, I believe you understand all of this. So it's also the same way that what do you call it now? That CGPA is work, right? Because different courses have different weights. So you have courses that are 2-unit courses, you have courses that are 3-unit courses, some departments 4-unit courses, right? So there's a way you just do the multiplication of the score, using the weights of those courses and then arriving at your CGPA at the end of the day. So one of the important things of learning about weighted average is for you to be able to manually calculate your CGPA by yourself, right? Okay, so yeah, that's it, 81.67%. I think I eventually did it. So in conclusion, with weighted averages, higher observations are better than lower observations in the cases where higher weights are allotted. So the summary of that is here, for example, since the higher weight is allotted to the examination, it is so great if the observation depth, observation x. Here now, this is this x observation. So this guy is x1, this is x2, this is x3. So x1 is 3, x2 is 5, x3 is 8, on and on like that. So she gets x5. So if the observation has a pretty high value, attached to the higher weight, that's about that. So the next thing I'll be looking at is properties of the mean. Yeah, cool. So properties of the mean, we are going to be talking about 3 properties of the mean. So number 1, we look at the deviation from the mean, the sum of the deviation from the mean. Now, the sum of deviation of a given set of observations from their mean gives us 0. So what exactly is deviation? Deviation is just the difference between a value and a reference value. So if you have number 1, our set of values x, like I showed you before we wrap up the whole thing. So you have x1, x2, x3, all of them fall under x. So what we're saying is that if you're summing the deviations, let's say we have x1, right, plus to x5, right? So the sum of the deviation is the sum of deviation from the mean x minus by x. So this is like x1, right? Then plus summation x2 minus by x, on and on like that, plus summation x5 minus by x. So when we do the whole thing, what we are going to get is 0. So that's what is meant by the sum of the division of a set of numbers from the mean, right, is 0. The sum of the division of a set of numbers from its own mean is 0. That is first property. So let's look at the stuff that we did that time. We had 5 numbers, right? And then we got a mean of 7.6, if you remember. Right, so we are going to be having the first one was 3. I think we had 8, 3, 5, 12, and 10. Can do 8 minus 7.6, right? That's the first number. Then the next one is 3 minus 7.6, 3 minus 7.6, then plus, I think we had an 8, 12, and 5, 12, and 10. 5 minus 7.6, 12 minus 7.6, 10 plus 10 minus 7.6. So when we add all of those, what are we going to be getting? This is 0.4, plus 3 minus 7 point, that's like a minus 4.6. This it's like a minus 4.6, plus into bracket minus 2.6, plus this should be 4.4, plus 4.4, then plus 2.4. So that's, I want to be sure calculation, plus 2.4. Everything when you add them together will give you 0. That's the first property of the mean. That's the sum of the deviations. Now these are the respective deviations. So you added up the deviation. That's what it means, that the sum of deviations. So you got the deviations first, then I added that sum of deviation. You added everything. That is the meaning of sum. Because it's plus, plus, plus. So you summed up the deviations. So when you sum up deviation of a set of numbers from its own mean, right, you are going to have 0. So yeah, that's that about that. Now the second property of the mean. And mind you, before we finish this, so you have an assignment. It was not part of the questions here. And the assignment would be to research on the like 3 advantages and 3 disadvantages of the mean, right? 3 advantages and 3 disadvantages of the mean. Or, anyways, maybe I just say it. So, one advantage is mean is pretty much easy to calculate. And number 2, it is used for further statistical analysis. For example, now in trying to get our deviations, we use the mean value. So that's what it means, that you use mean for further statistical analysis. So if you are looking for things like variance, standard deviation, mean deviation, we are still going to be using the mean. You understand? Now, on the disadvantage side, the problem with the mean is that it's affected by extreme values. Now, what does that mean? If you have a very high value, right, that is an outlier, a value that has characteristics entirely different, from the other values in a given data set, your mean, right, is going to be seriously affected, like negatively affected. We'll talk about that, eventually. All right. The second one is the sum of squares of a deviation. This deviation that we've gotten, the sum of squares of this deviation is the least, right, around the mean. Is the least when the mean is used. Let me put it very well. The sum of squares of a deviation of a set of numbers x1 is only minimum from the mean. Now, to explain that, sum of squares of the deviation. So what we are talking about here, we are looking at the sum of squares. So we have let's say xj minus by x squared. So sum of squares, right, of the deviation is minimum, right, about the mean or around the mean. So if you use a different value here, right, you are going to be getting a sum of square of the deviation that is greater than what you have gotten. So you are going to have the minimum sum of squares when you are getting the square of your deviation using the mean of that particular data set. So what do I mean? So let's give an example. Okay, so here the first one, 0.4, right? That's 8 minus 7.6. 0.4 squared plus minus 4.6 squared, 0.6 squared plus minus 2.6 squared plus 4.4 squared plus 2.4 squared. Alright, so when we do this, what we're eventually going to get, so I didn't memorize all of the answers, 53.2. 53.2. So what this is essentially saying is that if we, what we subtracted was the mean that we got. So we use a different value. Let's say you use 7.5 or use 7.7. But if the value is lower than 7.6 or higher than 7.6, you are going to get a sum of squares that is higher than 53.2. So now I solved this. I used, I tried 8 and yes, and I tried 9. So I thought I tried a lower number. Okay. If you try, okay, yeah, if you tried 8 instead of 7.6, you're gonna get 54. So if here had been, so instead of bar x equals 7.6, right? So let's say you use a, I call an assumed mean. We're going to talk about it in lessons in the future. So let's say you use an assumed mean of what is here, of 8. So here 8 minus 8, 3 minus 8, all of that. So your sum of squares by x squared will be equal to 54. So even though you use okay, 8 is greater than 7.6, fine. And let's say we use 7. So if a equals 7, the sum of squared equal 55. So 7 is even a lower number. And then if you decide to use a equals 9, right, the sum of squared equals 63. So I just try to solve it on my own, and then say, okay, wow, this thing is true. So for you to minimize your sum of squares, you must use the mean of that given set of data. For you to minimize your sum, so you'll be needing this in econometrics, right? Because when I was taught there, we were just saying some things, and that's why I didn't enjoy econometrics. So I thought I hated it. Like, even though the primary thing I wanted to study in the university was statistics, all right, and then based on a very good piece of advice, I need to go and study economics, which is broader than stats, right? And it's going to make a good use of stats. When I was being taught econometrics, I was being taught as if I'd understood all of those things from statistics. So it was difficult. I couldn't flow, right? So yeah, when it comes to things like this, just know it that okay, if you want to minimize your sum of squares, you need to use the mean of that data set. Any other number will give you a higher value than what the mean would have given you as far as your sum of squares is concerned. squares of the deviation, right? Sum of squares of the deviation is concerned. Now, number 3, if F1 numbers have a mean, number 3, so if F1 numbers have a mean of a certain number, maybe F1 has a mean of M1, and F2 set of numbers have a mean of F2, right? And Fn set of numbers have a mean of Mn. How do you get the overall mean, right? Because you could be asked, calculate the overall mean. So for you to get the overall mean, all you have to do is multiply F1 M1, F2 M2, Fn Mn, add them together, and then divide by sum of the entire numbers of frequencies. So what am I trying to say? Overall mean is going to be equal to F1 M1 plus F2 M2 plus Fn let me put it this way. So plus 3 ellipses and plus Fn Mn. So everything here will then be divided by F1 plus F2 plus F plus Fn. So the reason I put in Fn is because there are still a lot of numbers between 1, 2, 3, and then n. So just saying that there can be lots of numbers before we get to n, the final one. So how do we apply this? How do we apply this? So for example, we are given that F1 is 10 and M1 is 3. F1 equals 10, M1 equals 3. What does this mean? It means that the mean of 10 numbers is 3. So we are told that the mean of 10 numbers is 3. So what you are doing, the mean of 10 numbers, right, is 3. And then the mean of 20 numbers, how do you write that? That means your F2 will be 20 numbers, right? So the mean of 20 numbers is given as, 5. So the question then says, calculate the overall mean. So the mean of 10 numbers is 3. It could be said in words, and the mean of 10 numbers is 3. The mean of 20 numbers, right? The mean of 20 numbers is 5. So calculate the overall. I like that. What are they doing? That's nice. That's nice. All right. So what do we do? F1 M3. So 10 multiplied by 3 plus 20 multiplied by 5. 20 multiplied by 5 equals 30. 10 plus 20. So 30 plus 100 over 30. So that is 130 over 30. We have 130 over 30, and that's 4.33. 130 over 30 is 4.3. So the overall mean is 4.33. So you may be asked to calculate your overall mean. Right, so that is what you do, and let's calculate your overall mean. So if you have questions, of course, leave them in the comment section. So that's going to be amazing. We'll respond to them as quickly as we can. And then, if you remember when we're using economics, of course, there's going to be an assignment in this lesson as we're used to doing. So, of course, you know how to submit your assignment, and then you know who to approach and how to approach. That's to get whatever question you want clarified to be clarified. Right? But if you know any of that category of people, you can just leave your feedback, your comments, whatever in the comment section. We are going to try as much as possible to attend to it as quickly, as we can. So let's talk about outliers. So let's look at this. 5 students brought apples, number of apples. So in the first situation, 5 students brought this number of apples. This first category. Then the second category, we reduce the number of 4 students brought this set of apples. So a student brought 20 apples, another one brought 15, another one brought 18, another one brought 17, another one brought 14. Then here, 4 students, each of them bringing this number of apples. Let's find the mean of the first one. So by x1 is going to be equal to 20 plus 15, that's 35, plus 18 is 53, plus 17 is 123, and 123 plus 14 should be 137. So I have 137 divided by 5. 5 and 13 is 2, right? then that's going to remain 3. 5 in 37, that's 7, right? 5 in 37 is 7.4. So this is saying that on average, each child brought 27 apples. Like looking at the first set of data, on average, each child brought 27 apples. Does that make sense to you? Now look at what everybody brought. Like this 27.4 is actually 4 students brought apples that were not even close to 27.4, right? So it was only this guy that brought some that was, and even 27.4 is way below what he actually brought. So this kind of thing is not representative of your data, not representative of your data set. Why? Because there's an outlier. There is 70. So like it's just like bringing a machine gun like to a fist fight. So it's better to fight. Like the boy brought a machine gun. So that's how the guy bring apples, and people just brought 20, 15, 18, 14, and you brought 70. So you distorted your data for us. So 137 over 5 is 27.4. If you correct it, actually be right. 5 and 13, 2, remains 3, 5 and 37, 7 and 7 is 35, maybe. So it remains 2, right? 10 points, yeah, that should be okay. Now look at after removing the outlier, so let's find the average. So about x2, what's going on with you? 20 plus 15 is 35. 35 plus 18, 53. 53 plus 14 is 67. So you have 67 over 4. Again, 35, 53. 35 plus 32, that's 67. Okay. 4 in 6 is 1, right? Then remainder 2. So 4 in 27. Is that not 6? Yes, that should be 6. 4 times 6, 24, right? It remains 3. Then 4 in 30 is 7. Plus 4 times 8. Wait, 4 times 7 is 28. So it's, 4 times 7 is 28, right? And then we have okay, and we have 30, right? Which remains 5. So 4 in so we have 67 points, maybe 75 or thereabout. Yeah, something like this. So in stats though, 67.75 is same as 16.75 rather, is same as 16.7, right? So anyway, so look at this average. So on average, each child brought 16.75. So like on average, a child brought about 17 apples. 17 is not far from 15, 17 is not far from 18, it's not far from 20, it's not far from 14. So this is representative of your data. This is not. And because 4 kids did not even bring this value, and then you are finding I mean it's meant to be average, it's meant to be middle, of something, right? So this is an outlier, a value that has an entirely different characteristic from what do you call it now, the other set of values in a given data. So it may be a very high value, it may be a very low value, but it's not representative of your data set. So what you have to do in analysis is to remove the outlier. So that's why final year students are told when you are doing your data analysis, remove outliers from your data set, because what you're trying to look for is average of what you're doing, especially when you're doing regression, doing regression analysis. You're trying to find like the estimated average, right, from repeated sample. Don't worry, you'll know those things later. So it is just better to eliminate any form of outlier from your data set. This 70 here is worthy of questioning. You should question it, right? So how come there is a 70 where others have this, right? So it's possible that all of these guys are from moderate income families, and this person is from a very wealthy family that he brought something that is just way more than. Do you understand? So bottom line is that outliers affect the mean. So it's a disadvantage of the mean. That the mean is easily influenced by outliers. So it is easily influenced by extreme value. So this is an extreme value in this case. Extreme will be very high, extreme will be very low. As long as it is not representative of the other values in the data set, then it's an extreme value. Alright, so for us to have a really, really good analysis, we have to exclude any form of outlier. We have to investigate the outlier and eventually remove it from our analysis. So have something that's representative of what we are trying to do. Right? Because at the end of the day, remember I defined stats for you yesterday, or in one of the lessons, right? That is talking about how you organize data, collect data, present data, analyze data, to draw out conclusions that can be used to make informed decisions. You can't use this one now to make informed decisions, because whatever policy you're making with this, right, is not even going to affect 4 people. So it doesn't make sense. Right? So whatever policy you use this one to make, whatever decision you use this one to make, it still makes sense. It still makes sense. So the final thing about this class now is to look at our assignment. Nah, don't worry, don't worry, don't worry. It's simple. It's simple. Calm down. Calm down. So number one, 3 numbers have a mean of 4, 5 numbers have a mean of 6, 2 numbers have a mean of 5. Find the overall mean. Straightforward, right? And number 2, given the 4.0 grading system at the University of Ibadan, 70% is 4 points. So which means if you have 70% and above, so that would be greater or equal to 70% is 4 points. Then 60 to 69% is 3 points. 50 to 59% is 2 points. 40 to 49, 50 to 59 is 2 points. 40 to 49 is 1 point. And if you have less than 40 over 100 in an exam or in like your overall course grade, that's 0 points, nothing for you. Alright, so Solar scored 78% on a 3-unit course, 69% on a 2-unit course, and 65% on another 3-unit course in a given semester. Calculate a GPA. Alright, so let's see what you're going to do. Basically, it's talking about the weighted or average, so you should know what to do. Then B, if GPA of 3.5 to 4.0 is considered first class, 3.0 to 3.49 is considered second class or upper, 2.5 to 2.99 is considered second class lower, 1.0 to 2.49 is third class, and less than 1.0 is pass. So what class of degree is Deborah? Then C, suggest 2 ways. Is it Deborah now? It should not be Deborah, it should be Gbemisola, please. So I don't confuse you. Yeah, what class of degree is Gbemisola? So from your results, from your CGPA, you will know. So just fix it. Where does it fall? Then suggest 2 ways to improve our performance next semester. So that's about that. See you in the next class. Thank you so much for coming. Bye.